a representation about our works on bi-directional social influence and information cascade using graph sequence attention network. We are from South China University of Technology. If you're interested in our works, you can scan the QR code in the PowerPoint. Oh, sorry. So what is the information cascade? Let introduce the concept of information cascade. The information cascade can be also interpreted as a information propagation network. So a dynamic cascade structure is formed when when an idea or information or Twitter propagate among users. So online network. A cascade can be modeled as a graph sequence. So let's say the following, the picture. Each node can be a user in online social network or a paper, and the links between the nodes can be the relationship between the nodes. It can be citation relationship in the paper, citation network, or the retweeted relationship between the node, between the user in social network like Twitter or Facebook. So it has a social, speaking of the social influence in information cascade, it has a two effect like social influence decay and a delay effect. Sorry. Then some people would choose to retweet a message or cite a paper after several times, not instantly. And the people folks, if we draw a distribution of the repeated time, it roughly follows a Pavlov distribution. Most people would like to retweet a Twitter in early time rather than in late time. But if some herb nodes join in some time, we can. There's still some more people would like to forward the message. So the bi-directional social influence is that if we only learn this one directional social influence, we can get a node, a herb node. Let's say a herb node retweet a Twitter, post a Twitter. So you can learn the social influence of the herb node on other nodes. But if more nodes join in retweet the message has higher probability to expose to other nodes, so we can improve the influence of the herb node. So it actually is a bi-directional relationship. So the problem, so this is a description of how cascade grows. In the early time, several nodes join, but with the more node retweet the node, and more people know the message, and it will draw attention of interested people. And the problems in this paper is predict the growth of the cascade. And finally, we have a cascade like this. So the model is we use we borrow it's motivated from the transformer network. So we use a graph transformer block to learn the both structure and temporal information of the dynamic graphs. Then we use a transformer encode block to learn the sequence problem, to learn the sequence relationship between the subgraphs, between the outputs of the graph transformer block. Then to make it in detail, we can later introduce, we use a graph in attention mechanisms to learn the relationship between the nodes relationship. Different from the graph attention network, this attention we design is we use a shared matrix between these nodes, and we use a graph pro and to learn the whole representation of a graph, actually a subgraph in each time. Then we use a graph sequence attention to learn the long dependence relationship between subgraphs in each time. Then we summarize the approach of graph transform blocks. We compare with some models with some strong lines published in top conferences. The dataset is from the microblogs and APS citation networks. This datasets record all the trajectories of online messages and ideas. So the performance we can is listed on the table. We can see that our proposal model have a much lower error compared with strong lines. So when we draw attention widths in the model, actually there are many attention widths. We only choose one. We can say that a subgraph, let's say in 11th time, is related with previous graphs and previous subgraphs and later subgraphs. So it's a bi-directional process. It's not one direction. So, and we can see the early we do prediction, the more challenging the prediction is, the better performance has achieved. So to conclude, the bi-directional social influence occur in information diffusion and has impacts on information diffusion. By considering this effect, we can improve the performance of popularity prediction. And the transform network is first extended in our work on graph sequence problem and to capture the bi-directional and long dependence between the subgraphs at each moment. Thanks for listening.
Thank you, Zhenhua, for the presentation.